We want to understand how factoring is, for us, going to give us the ability to do things that without it we wouldn't otherwise be able to do. So just as an example, and I don't want to go through the details of how this example works because that's for next month sometime. But if I want to solve an equation like, so let me just pick an equation out of a hat here. X squared equals x plus 6. So here's an equation that has a single variable in it, x. Right? Now that variable happens to appear on both sides of the equation. The unfortunate part is that the two places where it appears are not like terms. Right? On the left side of the equation we have an x with a power 2. On the right-hand side, x with a power 1. We also have this other unlike term that's sitting out in the front, the constant. So all three of the terms in this equation are unlike to one another. So if I want to solve this equation, the tools, the techniques that we've been talking about over the last week or so are not enough. It's not enough just to follow our general strategy. And our general strategy would say, let's first try to simplify both sides. Okay, done. We can't simplify this any further because those aren't like terms. I can't simplify this any further because there's nothing else to do. All right, so the simplifying is done. So the next thing that we would do, so one, simplify. The next thing we would do is try to get all the variables to one side. Okay, well that we can at least do. And that would look like, what I would actually want to do with this is I would want to subtract the x. And I'd probably also subtract this 6. I'll do that in a second step. Now what do I have? On the left-hand side, I have a subtraction problem, x squared minus x. This is a polynomial subtraction of the kind that you just practiced a few minutes ago. But because those are not like terms, how do we do x squared minus x? We don't. We just leave it as x squared minus x. Right? We can't make that any simpler. And then likewise, when I subtract 6 from both sides, I also can't do anything to make that any simpler either. X squared minus x minus 6 is equal to 0. So now I've succeeded in getting all my variables to one side. But then in our general strategy for solving an equation, we would try to use the reverse order of operations to unwrap the x. So unwrap the x using SADMEP. The problem is that my x exists in two different places. And I can't try to unwrap one of them without screwing up the other. Because x squared and x are not like terms. I can't get them together. So I can't get them into one place where I can target and unwrap. Right? And so this step is not going to be enough to do it anymore. So we need new technology. We need new tools. And so here's where the new tool comes in. If we can somehow factor this quantity, x squared minus x minus 6. So let's imagine that we can. Write it as something times something. That's what it means to factor, right? If I can factor it, and for today, let's not worry about where this factorization comes from. That's a bridge that we'll cross later on in February. But if we can factor this equation, then here's where the magic happens. Then I have two different quantities. I'm going to highlight them in two different colors. Two different quantities that when I multiply them together, I get 0. So how do you multiply two numbers together and get a product of 0? Yeah. The only way to multiply two numbers together and get a product of 0 is for one of those numbers to be a 0. Right? There's no other way. If I take a non-zero number and I multiply it by a non-zero number, I'm always going to get a non-zero product. So the only way to get a 0 product is for one of those two numbers to have been 0 in the first place. This is something that we call the zero factor property. Zero factor property. And what's great about the zero factor property is what it does is it gives us two equations to solve that are simpler than the original. Because each factor can itself be 0. we can solve each one of those two equations separately. So in the first case, if x minus 3 is equal to 0, how do I solve that equation for x? How do I get the x by itself there? Add 3 to both sides. And I find out that, in that case, x must be equal to 3, and we have a solution. Likewise, if x plus 2 is equal to 0, how do I get that x by itself? From here, I would need to subtract 2, and if I do that from the right-hand side, I'll get x equals minus 2. And at that point, now we're all the way home. We have a solution for this equation. The hard part of this process, though, is that it really relied upon us being able to do this. Right? Being able to go from this expression, which has a bunch of unlike terms that we can't do anything with, and then reinterpreting that as a product, right? Factoring it into a product of one expression times another expression, and because a product is equal to 0, we can split that product into two pieces and solve each one of those simpler pieces separately. And so the key step in this whole process is right here, and this is a big if. Right there. If we can manage to factor this left-hand side of the equation, then we can use this awesome property and it gets us all the way home. But if we can't factor it, then either we need to use some completely different tool in order to do it, and it'll be until April before we see a different tool to do that, or we just can't do it. And there will be equations like this one in this course that we just don't want to solve because the solutions are either nasty numbers, not whole numbers like we have here, or the solutions might not even be real numbers at all. There may be no number in the real number system that satisfies an equation like this. But so that's a big if. But the reason that we want to factor is so that it can give us the tools to do this kind of thing, to solve these kinds of equations that our general strategy right now is not powerful enough to solve.